Zoe, what are you doing?
It's a secret, no peeking.
If you're drawing me again, give me a stronger jawline. Last time I looked like two flashlights taped to a gallon of milk.
Have you looked in the mirror lately?
Oh, come on, Zoe, show us. The suspense is killing us. What was that?
Ooh, that was scary.
Your paper just disappeared. Where did it go?
I don't mean to panic, but mystery alert, mystery alert! Paging Dr. Jeff, paging Dr. Jeff, paging Dr.
Did somebody call a doctor?
We don't need a doctor. We need a detective.
Well, you were in luck because I am an expert at solving mysteries of science.
Anyway, where's the paper?
What happened?
Zoe's paper. It just vanished in a ball of fire like some kind of crazy magic trick.
It wasn't a magic trick. I was writing my notes on flash paper and burned it up.
Yeah, but where did it go?
Aha! I think I know the answer to this mystery.
Uh-oh. I think a lesson is coming.
I'm Dr. Jeff Vinegar, and today we'll use the law of conservation of matter to understand where things go when they seem to disappear. We'll see what happens when things change, when they seem to disappear, and when they seem to appear out of thin air. With Dr. Jeff. Welcome to Labracazam, where we make science make sense.
Dr. Jeff, I don't get it. That paper, like at first I could see it and then whoosh, I couldn't. Where did it go?
Well, it had to go somewhere. Why? Because of the law of conservation of matter.
Matter is anything that has weight and takes up space.
Right. And the law of conservation of matter says that the amount of matter stays the same, even when it changes form.
That's confusing. Could we break it down?
You know it. Let's break it down. Let's start with a simple example to understand the law of conservation of matter. First, we'll start by weighing out 25 grams of sugar. Perfect. Next, we'll weigh out 150 grams of water. These scales are set so they don't weigh the weight of their containers. We want just the weight of the sugar and the water. Yes! Now we simply mix the sugar into the water. Here you go.
It looks like the sugar disappeared.
But it just dissolved, right? The sugar's still in there.
Well, what evidence do we have that it's still in there?
We can weigh it. If it weighs 150 grams, then that means the sugar is gone.
And if it weighs 175 grams, it means the sugar's still there.
Let's try it.
175 grams. That's the weight of all the water plus the sugar.
Even though we can't see it.
The sugar is still in there. It didn't disappear. The law of conservation of matter tells us that matter never just vanishes. We can get more evidence that the sugar is still in there by boiling it. This makes the water evaporate more quickly.
As the water evaporates, you can see all the gooey sugar.
So the sugar was in there the whole time, even though we couldn't see it.
Right. Now let's move on to a more challenging example. It's called the fire snake. Don't try this at home. This is a dish of sand, which I am now treating with a highly flammable liquid. Zoe has 20 grams of sugar, and Izzy has 5 grams of baking soda. Now let's mix them together.
This mixture now weighs 25 grams.
Excellent. Let's pour that mixture onto the sand and light it on fire.
Snake!
Relax, it's not a real snake.
It looks like a snake just grew out of nothing, but all it was doing was foaming. Burning this mixture creates a lot of carbon dioxide gas. all the bubbles and make it appear really big.
So where did all this stuff come from?
Remember, the law of conservation of matter tells us that when matter changes form, it's conserved.
So when you take out all the gas bubbles, it should weigh about the same as the stuff we started with.
Let's try it out.
Be careful, Zoe. Snakes can be very unpredictable.
Again, Bert, it's not actually a snake.
This one weighs a little bit less than 25 grams.
Where'd the rest of the matter go?
Some of the matter became a gas and escaped into the air while it was burning.
So it's the same amount of matter, it just simply changed forms?
Labracazam. We just saw when matter seems to appear. Now let's look at the opposite, when matter seems to disappear. This is a piece of dry ice. It's made of carbon dioxide gas.
Hey, that's the same gas that's in carbonated drinks.
When carbon dioxide gas is squeezed really, really hard, it turns into a solid. My mom had to find out the hard way.
Jeffrey! I ordered this ham from the old country. Look, it's on fire!
That's not smoke, Mom. That's carbon dioxide gas made by dry ice getting warmer.
I know smoke when I see it. Curse your ham on fire!
But dry ice doesn't actually melt, does it? That's why it's called dry ice?
Right. Dry ice changes directly from a solid to a gas without becoming a liquid first. So it's perfect for shipping things like frozen foods. When I put this piece of dry ice on our scale, we can see that it weighs 243 grams.
Actually, now it weighs 242 grams.
Wait, now it's saying 241 grams.
Is it getting lighter?
As you can see, it's turning into a gas. If we waited long enough, the whole chunk of dry ice would turn into a gas. It's almost like it's disappearing.
How can you prove it's turning into a gas?
I can show you. First, let's weigh all of our equipment on the same scale. We're gonna use a flask, a balloon, and a few pieces of dry ice.
Altogether, it weighs 152 grams.
Great, now we just put on the balloon. Now we wait.
The dry ice is getting smaller and smaller, and the gas is inflating the balloon.
That's so cool. But look, the weight isn't changing.
The dry ice is not disappearing, it's turning into a gas. The total weight of the matter is the same, even after it changes form.
Because the matter is conserved.
I get it now. Let's explore some more examples around the house with some real-world science.